To solve this system using Gaussian elimination, we are going to start by writing down the augmented matrix that corresponds to this system. Now, this is sometimes referred to as a non-square system because we have more variables than we do equations. We have 3 variables but only 2 equations. So whenever we get a problem like this, it's either going to be no solution or infinitely many solutions. There is no way to get just one specific answer in this kind of a situation. So we proceed the same way as other Gaussian elimination problems. We have a 1 here in the top left, and we want to get a 0 below it. So we're going to multiply row 1 by -1 and add it to row 2, and that will give us our new row 2. Okay, next we want to get a 1 down in that next spot in that diagonal. So here we have a -1. I want that to be a +1. So I can just simply multiply row 2 by -1, and that'll give me a new row 2. And now I want to get a 0 here above that 1, and that way I'll be able to get 2 equations that just involve 2 variables instead of all 3. So to get a 0 up there, we're going to multiply row 2 by -2 and add that to row 1, and that'll give us a new row 1. And now going back to the corresponding equations, this top row says 1x, or just x, minus z equals 50. And the second row says y plus 2z equals 10. So I can solve this first equation for x by adding z to both sides. So I get x in terms of z. And I can also get y in terms of z by subtracting 2z from both sides of the second equation. So the x-coordinate depends only on the value of z, and the y-coordinate also depends only on the value of z. So this is indicating that z really could be anything, but whatever number we pick for z, the x is that number plus 50, and the y is -2 times that number plus 10. So there are infinitely many solutions because we can pick any number we want for the z-coordinate, but they all follow a certain pattern here that we will write down in our ordered triple. So our general solution has an x-coordinate of z plus 50, a y-coordinate of -2z plus 10, and a z-coordinate of z, meaning that could be any number.